This video is going to cover question 3, part C from the 2021 AP Calculus AB free response, no calculator required section. I cover each of the portions A, B, and C in their own videos, so if you want to see A and B, go ahead and check out my other videos. For this problem here, we've got this spinning toy, and they're telling us that it has a volume of 2 pi, and they want to know, again, what is the value of C? So what we're doing is we're taking this shape here and we are rotating this thing. So we are spinning this around. And so what that means is, because there's no gaps in it, you're kind of looking at either a disk method or a washer method. If there was a hole in this, if we had some other shape coming through like this that created a hole, we'd be looking at the washer method. But luckily for us, we are looking at a disk method here. And so what we'll do for the disk method, it's just an integral formula we need to know. It's the integral from A to B of, it's basically the area of a circle formula if you think about it. It's pi times whatever your radius formula is squared dx. So if we put this together for our specific example here, back on part A, if you want to go back and check it, we found where these bounds would be. This would be at 0 and this would be at 2. Those bounds for this shape here did not get affected by what the C value was. So no matter what our C value is, we know that our lower and our upper bounds are going to be 0 and 2. So we have 0 and we have 2. We're basically putting this formula together. Then we get pi, and now what we need is we need a radius formula. Well, our radius is this shape right here. From there to there, it's the height, because as we move down this, wherever we run into this equation, that is our height. So that would be our equation, c of x times 4 minus x squared. So this will be our radius formula, because that's going to tell us what our distance around there will be at any given point. So then we plug our radius formula in, c times x times the square root of 4 minus x squared, and then that whole thing is squared right there, dx. And from here, it's just really going to end up being an integral problem. And what we'll do is at the end, remember, we know that this volume here, this all has to equal 2 pi. So we're essentially going to solve this left equation to get down to where we just have a bunch of values in it with a c there, and we'll set that equal to 2 pi and solve for c. The first part of simplifying this down is going to be a little bit of laws of exponents. Because these two chunks are being multiplied, I can actually kind of distribute this squared into both pieces. I can square these things and I can square those pieces. So as we rewrite this, we're going to go 0 to 2. This will be pi. That's going to be c squared, because we can square the c, and then x squared right there. And then when we square our square root, we're going to end up canceling out that square root and getting 4 minus x squared dx. To make your life easier on this, before you dive in, you kind of want to pull constants to the front if you can. All of these things are being multiplied right here. Those are a bunch of constants. So we can pull a pi and we can pull a c squared to the very front, and that's going to leave us with the integral from 0 to 2 of x squared times 4 minus x squared dx. Looking at this problem, we don't want to just rush in to take our integral. We just keep looking to see what we can do to simplify. And unlike part A, where we ended up having to do a u substitution, there's no power on that 4 minus x squared. So really what you can do is go ahead and just distribute this x squared into both pieces here. And in the end, we're just going to be looking at a pretty straightforward power rule. So distributing the x squared, 4 times x squared is going to get us 4x squared. X squared times x squared is going to get us minus x to the 4th dx. And now we're ready to go ahead and just apply our power rule for antiderivatives. So my power rule for antiderivatives, my saying goes add 1 to the power and then divide by the new power. So we'll come through here. We got this pi times c squared that will end up multiplying by our final answer here. So this will be add 1 to the power. That's going to get us 4x to the 3rd, divide by the new power, minus add 1 to the power. That gets us x to the 5th, divide by the new power, and then we're going to evaluate this now because it's a definite integral from x equals 0 to x equals 2. And from there, I do what I just call top minus bottom. I'm going to take the top value, plug it in, and then I'll subtract off of that the bottom value plugged in. Remember that all of this needs to get multiplied by this pi times c squared. When you pull your constants to the front, they just kind of stay there, and you multiply them by whatever your final result's going to be on the other pieces. So we keep running through our algebra here. So that we got our pi c squared sitting up front. We're going to now plug in the top value. So this is going to be 4 times 2 to the third over 3 minus plugging in 2 to the fifth over 5, that first chunk, minus plug the bottom value in. You know, the nice thing about the bottom value getting plugged in is it's just going to be a 0 everywhere. So even though we kind of track it to make sure we don't forget to do anything, that's just going to be 0. Because just as you think it's 0 every time you plug in 0, they'll do something a little funky on that equation and it won't work out. So just kind of double check your head before you get going there. And now we're going to come through and we're going to just keep working out this algebra here. So then 2 to the third is going to be 8. 8 times 4 is going to be 32 over 3 minus 2 to the fifth would be 32 over 5. And now we get the pleasure of kind of putting together, we've got to find our common denominator here. And, you just got to be so thankful that you don't have your calculator, right? So the common denominator would be 15. The easiest way to find a common denominator is always just to take the bottom from one fraction, multiply it by the top and bottom of the other, and then we'll do the same thing over here. So we got our pi c squared out front. We do 5 times 32 is going to get us 160 over 15 minus 3 times 32 is going to get us 96 over 15. Again, just, take it a step at a time. Take it a step at a time. Pi times c squared, 160 minus 96. When we're just combining those top pieces there, that's going to get us 64 over 15. And then bringing that together, finally that's one number, so we can multiply this. This is going to be, keep the c squared as its own piece just because that's what you're going to end up wanting to solve for. And so then on the top here, we would have 64 pi over 15. So remember that was this half of our equals, that we found out what that was. And what we're trying to find is c when it equals 2 pi. So from there, we kind of grab that 2 pi and bring it down below here. We'll kind of move ourselves over and get a little bit more room to do some algebra. So we'd have c squared, 64 pi over 15, and we know that needs to equal 2 pi. So solving now for c squared, we would multiply both sides by that reciprocal. It's kind of the easiest way to move this over to the other side. A lot of people think about it as division, but if you do that, it becomes like fractions over fractions. Remember that multiplying by the reciprocal can get you to the same place because 64 pi cancels 64 pi, 15 cancels 15. We get c squared. And as you come over to the other side, kind of look to do some simplification before bringing it all together. Pi on top cancels with pi on bottom. 2 on top is going to cancel with 64 on bottom and get us 32. And then from there, we would end up with 15 over 32. And now we'll go ahead and square root both sides of this thing, and we should basically be done. So we'll square root both sides. And we end up with c equals plus or minus the square root of 15 over 32. Remember, when you apply a square root, you have to have the plus and the minus. But when you go to say, well, which is it? Odds are they've probably told us something about c back in the beginning of the problem. And sure enough, up in the top here, they tell us that c is a positive constant. So we know that of our two options, we don't care about the negative version of this square root, that in the end, we would be looking at the positive version, square root of 15 over 32. And I would leave it right there, especially because you don't have a calculator. And that's going to be your final answer. Again, c is a parameter. It's a constant. It doesn't have any units, so no units attached. And out of this problem, this one was a biggie. This was going to be worth 4 points. So from here, you would have gotten 2 points basically for setting up your integral with the bounds back up at the top here. That would have been 2 points on that portion of it. Getting out your antiderivative, just kind of getting to this stage of the problem right here, would have earned you another point. And then the rest of that algebra from there all the way to the finish line over here, that would have been another point. This was a big portion of this problem. This was a 4-point piece. So that's how you get them all, though. Thanks for watching my video. If you liked it, please click that like button and subscribe. And also share it with your friends and anyone else you know who might be crying about an upcoming AP Calc test. You can find more videos from me, more sample AP Calc questions, and my complete AP Calc study guide over at my website, apcalcprep.com. Have a great one.